So hello everyone, and we are continuing the streak of interviews here at MLOps World Conference. And right now I have a really amazing guest because this is Rajiv Shah from Hugging Face, and he is a machine learning engineer there. And I think we'll have a very interesting discussion about some of the things that are going on in there. So how did you end up in Hugging Face? What's your journey overall in MLOps and ML?
Yeah, so Hugging Face is a pretty unique company and focused on open source. For me, I was drawn to them because the way I got into data science and machine learning was because of open source. Those open source tools made it easy for me to learn and skill up along the way.
Yep.
Right? We had the NLP revolution over the last few years, and I was just like, I want to be part of that. I know that there was a lot of growth and excitement there. And so I joined the company about a year and a half ago as a machine learning engineer, and it's been fun following it all the way through, the rapid growth of things like diffusion, and then now with kind of generative AI and large language models like that. So it's a great time to be at a company like this.
And what were the few kind of highlight projects that you were working on, just from out of interest?
Yeah, for me, I typically work with enterprises, kind of helping them solve problems with that. So I've got to kind of vision. I can't talk about all the
of course not.
like that, but I've got to see them kind of build models, pre-train them from scratch and do amazing things, or just even fine-tune models to solve simple problems and get huge boosts in performance like that. So it's been fun to see all the new types of use cases that people are able to now tackle kind of with the broader use of kind of generative AI like that.
So it was mostly focused on generative AI, right? Not regular models.
So when I first came in, it was before kind of ChatGPT. And so a lot of the use cases were focused around typical text classification, or maybe some document AI where we want to extract information out of PDFs like that. But now, as people have been introduced to kind of what you can do with large language models, it's a much broader set of, let's do code completion, or let's do the RAG use cases and extracting information, all the way to people that want to do very advanced things with agents and all the kind of the pushing the edge envelopes.
Yeah, so agents are a very interesting topic, but maybe let's start with...
They're much more research.
Easier ones. But I guess there are a lot of challenges still in regular LLMs. Yes. We now have regular classical ML, we have classical LLMs, and we have agents. So what about classical LLMs? What are the main challenges that you're currently observing?
So one of the things I see repeatedly and kind of motivated my talk is I see everybody's experimenting with these, right? Everybody's they're downloading these things, they're doing demonstrations of that, right? Their executives are getting excited, but there's a huge problem between moving these quick demos that people are doing to things in production. And I think part of it is we don't have a good framework for thinking about how to evaluate these technologies. And so that's where I kind of focused my presentation at the conference was, let's have a more structured way to think holistically about the entire modeling process. Because if we can do that, then we can show a couple of things. We can show the value of a project, that, hey, it's worth the resources to build something like this. It's worth it to host GPUs like this. But we can also start decomposing it and start figuring out where the problem spots are in our application and what are the knobs and buttons we need to tweak to kind of help improve that overall performance.
So what is the current state of the art when it comes to evaluating large language models?
So, especially for folks that either are new to machine learning or come from very classic data science, it's a tough, because you're used to I have nice discriminative outputs. I just have 3 categories that I have. And now, right, you ask an LLM for an output and you ask it, tell me if it's a positive or negative sentiment. An LLM will tell you positive or negative sentiment in 6 different ways. It's very hard to narrow and scope it out. So the difficulty is these generative models they can have such a diversity of outputs. So it becomes difficult to think about, how can I box them and how can I start evaluating which ones are ones that are meeting what I need for a project and which ones aren't. And so there's a whole suite of techniques that we can use them around them. I think some of the more exciting ones is the model-based evaluation, where you're using another model instead of, humans are expensive. You can always have humans look at things, but humans are expensive. So if we can use another model and substitute that in to help do the evaluation of these.
And are there any, white papers or proven results that this is maybe even the best way to do evaluation.
Yeah, so it's so new, right? Like this model-based evaluation is really with the latest models, things like GPT-4 that are very good at doing this, and with an increased need of like so many people are building these use cases and we need some way to evaluate them. There's been a lot more emphasis for doing this. So we're all still learning. Like literally my slide deck gets updated almost daily or every couple days because there's new papers that are coming out as we figure this out. But it seems like a pretty reliable way of doing it. Now, you can't just blanket use it, but used in conjunction with other things, that these models are kind of very an effective tool.
And what is this way of evaluating model? What does it play against? Like, what are the other ways of doing it?
What are the
other ways of doing evaluation? I know that there's human feedback, right? But you can't do it at scale, right? You still need some sort of a metric type of evaluation if you want to do it at scale, right?
Yeah, I mean, so there's always the humans, but the humans are, they're expensive.
Slow.
Depending on the human you get, slow, they're varied. Are you getting them in the morning where they're cranky, or are they happy in the afternoon, right? Or there's different domain areas of knowledge like that. So there's a lot of variability, but then also humans are, again, expensive to kind of get that labor to do that. Now, the models can be good, but again, you have to like watch the scope of what you're doing. So if you ask a model, for example, was this toxic or not? Is this appropriate content or not? Like models can kind of gauge that. They can gauge what language is the output. Was it, in English? Was it in Spanish? So there's areas that the models are very effective as evaluating. Like they can't entirely substitute for humans. Humans have such broad range and kind of judgment like that. But if we can take that problem and at least narrow that down, and whether it's identifying like this is a good, a good result because of these attributes, or the other thing that often happens is we worry about how these models can go wrong, right? Especially if they're customer facing like that. So we can use these models as a way to kind of double check the outputs before customers go to it, as a way of like red teaming all of these types of outputs as well.
Just check if they didn't jailbreak, right?
Yeah, exactly. Like a second set of eyes on this. That's
And when it comes to evaluation, is it the same for okay, so we have fine tuning and we have prompt engineering, right? Will you perform the same evaluation procedures in both, or is it a little bit different?
Yeah, I mean, you can do, what happens often is when people are often doing prompting, they just kind of look at a couple of examples.
Yeah,
that's good enough. Like, it's very easy when you're prompting to get away from a very rigorous approach like that. So we want to add that rigor into prompting. With fine tuning, usually you're adding that rigor there, but often you narrow it down to just some very quantitative metric that's very easy to do. And so you miss the broad richness of the possible outputs and the issues that you might have with this. So for example, if you're building something to summarize emails, like it's really hard to quantify that summarization, that it's very accurate, especially because these models nowadays can do like near human quality summarization.
So I guess you employ other large language models then to evaluate the summarization, right?
I mean, that's one way to kind of make sure.
Okay, and okay, what are your thoughts about? And I know you're in Hugging Face, right?
Yeah.
Fully open source. But then again, there are these proprietary APIs like OpenAI, right? So how would a process of choosing a model and fine-tuning it to the end result that you want to achieve, how would it look like? Of course, because like originally you also probably have an option to choose also proprietary API, right? So how would you go through a process to actually come to the conclusion that you need to use open source?
Yeah, so I think, I like having a market which has lots of options like that. It's great. Like OpenAI has built some very good models, but they have their own kind of economic incentives, and they've kind of not told us exactly how they're building the models, right? All you have is access to an API. The model can change at any time. You have to send your data, right? So there's, like any engineering decision, there's trade-offs there. I often recommend to people, like, use OpenAI early in your project. Like, it's a quick way to kind of do a POC, to test something. Like, I play with it all the time like that. But often what happens is you get that running, then the next question, especially for enterprises, is, well, we want control over this model. We want to keep it private, right? We care about security, right? We don't want to send our data across. And so all these concerns, then people are like, maybe I should think about the open source. And then that's often when I work with them on the open source models and kind of going through the process of fine tuning and getting the models.
And I guess it's a big process. So in your observations, so how hard is it to actually fine-tune something that is fit for your use case? Because even like Llama 2, right, they are already good, but not as good, right, as GPTs. So,
and it's actually a very difficult question that you answered. On one hand, it's very simple, right? There's simple tuning scripts, couple lines of code you can fine tune.
Come on.
Like every data scientist, every person's like, oh yes, I can fine tune a model like that. But what you also instance is for your task, and this is where it gets tricky. Like depending on your specific task, like have you built, a training data set for that fine tuning with examples of, what you want? Have you built the evaluation? That can often take a little bit of work. And often when we have those people building those quick 10-minute demos for the executives like that, right, they just use the standard examples off that. Like they don't take into consideration to tailor it for our use case. Somebody's got to have to go out and find all that data inside the enterprise, right? It's in 16 different silos. You need some experts that understand it, that can make sense of it. You need some time to pull all that together to make those quality things. And I think sometimes we undervalue that in this like rush to kind of ChatGPT everything.
So did you see a lot of successes? Were there failures? Like I can imagine that you would come to some enterprise, you kind of tell them what needs to be done because you know what needs to be done. And it's impossible, right? Because the data is not there, not high quality enough. Maybe, okay, so there's a script that allows you to do it easily, right? But you need data, right? So are there a lot of these kinds of cases?
There's plenty of those cases. But that's also where analytics is now mature. Like 5 years ago, that happened all the time, and it kind of before LLMs, but just traditional data science, where enterprises weren't ready at all. They hired people, they hired a deep learning researcher, and then they realized they don't have any data. Most places are a little bit better now in terms of like, at least they can prioritize. Like they might not have for that particular LLM project the data ready, but they have other work, and then they can start spending time getting the data quality ready. So, 6 months or a year from now that you can build it. So most enterprises are a lot more mature like that, but again, it's like a prioritization type thinking that you have to have when you're doing this.
So we kind of eventually succeed, right? That's what you're saying. Not all of them.
But it comes down to the use case. Like, what's the value of the use case? What's the difficulty of doing it? Like, some use cases might have little value where you could spend a lot of energy doing it, but like, it's not that useful to the business like that. So you want to avoid those things.
And I guess fine-tuning is not the only thing, right? So even if you fine-tune, you want the prompt engineer and... in your experience, how kind of given a split? So what part of the entire training job is fine-tuning? Which part in percentage of time taken is not fine-tuning, but prompt engineering?
Yeah, so it depends a little bit on kind of what you're doing like that. Like sometimes you can get really far with prompt engineering, and it's a very effective technique. Sometimes it makes sense that I want to change the underlying model itself. I want to change the weights and use the fine tuning. So a little bit of it depends. Usually for both of those, it's not that long. Like fine tuning or prompting you can literally spend a couple of days or a week kind of getting that prompting. Fine tuning, depending on that data availability and ready, right? That's still just a couple of days, a week or two. If that data, like those are often kind of very small parts of that overall kind of life cycle. Because the other thing, right, this conference talks about is deployment of these models and how you actually work inside an enterprise to think about that piece, because that can be a whole nother issue when it comes to large language.
And do you have any insights from this specific area, like deployment?
I think this is an area that a lot of people are still trying to figure out, partly because there's challenges, because partly availability of GPUs. Most engineering teams haven't had sufficient time to work with GPUs. They're very comfortable, IT teams, with CPUs, but GPUs bring a whole new set of skill sets that they're not all on. So this is something that, like, at the beginning of that use case, like, you need to figure out, like, what we could actually get into production at the tail end and what are the resources that we have.
Because this is also about, like, there are probably use cases that do not require latency, low latency, right? So then you can maybe squeeze some of the models into CPUs because they are now also smaller, becoming smaller, quantized, right? And is it something that you see in the industry? Meaning that are people always going with GPUs, or is there a movement towards CPU-based deployment?
Yeah, so like traditional kind of BERT-based NLP models, there was still BERT, ran great on a CPU. Lots of people, right, was still one of the most used models that is out there. Now with LLMs, what we're seeing is there's a huge market that's really focused on the efficiency of these and trying to run this on CPU. So you have all these quantization techniques you talk to, right? There's people even running it on like iPhones and doing that. So we see there's a ton of research and a ton of development there for doing that. I think that's going to progress. People are trying to eke out as much as they can with smaller models. So I don't know. There's not a lot of LLMs right now that you could run effectively on CPU, but people are moving towards that. And so I think we're going to see, plenty of smaller models that people can run because, right, CPUs are cheap. They're easy to kind of run like that, especially if you have large amounts of data that you can wait a little bit. Yes.
So what kind of latencies have you seen squeezed out of a large language model? Because, if you're using OpenAI or similar systems, then it's numbers of seconds, like 7 seconds, 9 seconds, right? But for some high volume use case, you might need milliseconds, right?
Yes.
Is that possible?
So it goes again to depending on the use case. So if you're doing something like a classification type project where you're working with encoders, you can get down to that. If you're doing something where you're generating that entire email summary, well, that time to that first token can take a little longer. Now, one of the advantages of self-hosting a model is you can control and kind of that latency, because often when you're using some external API, your latency is going all over because you're sending that out. You don't know when that's coming. But if you can control that environment yourself, you can have kind of much tighter kind of bounds on what that latency is going to be and have much lower latency as well, depending on it. Now, the latency, of course, depends on the exact model you have and what you've done, quantization, all the different techniques like that. But yes.
So do you see large language models replacing some of the more general use cases? For example, we have and probably will always have stuff like personalization, ranking, etc. Do you even see at some point in time large language models coming into that area? Because now probably not, right? Because we have XGBoosts and regular deep learning models for that. They're fast.
So I think in some ways they will. So, part of the what's great about large language models is they're just so flexible. They can handle so many diverse tasks and so many diverse types of inputs. So, as we solve the problems around, cost efficiency and the red teaming and inappropriate use of that, I think because they're so flexible that we want to use, right, it would be much easier if we can have one large LM handling what used to be 10 other models inside an enterprise in terms of maintenance of all of that. So I think there will be a momentum to try to squeeze out as many as we can out of an LM.
Okay, and maybe one last question. So from your experience, you saw a lot of systems like this being deployed on premises, I guess, using open source. So what's the general sentiment around the price? Is it still cheaper to use something proprietary like OpenAI APIs, or is it already kind of a movement happening towards the fact that maybe it's cheaper to do it in-house? Because I don't imagine it would be cheaper, at least. Okay, if you need scale, then probably yes, it's cheaper to do it in-house.
Yeah, so it's a very context-specific thing. I mean, one of the things OpenAI has been very aggressive with is the pricing. I think that's one thing they've realized is that they have to keep that price very low. And so it's a very competitive offering, especially if you're just doing a little bit of predictions. And this is why I think a lot of developers start with OpenAI. It's much better on the price. Usually right now, the enterprises that I see that are doing the self-hosting care a lot more about other issues than price, right? It's the security, the privacy, the control, all of those things like that. So I think, that will come into play over time. I think for companies like OpenAI and other proprietary ones, if they spend their time optimizing their models, right? If you have one general model and you can spend time optimizing it, you could probably squeeze more out of a GPU that way than somebody that's kind of self-hosting a model like that. But this is where, right, there's lots of choices and lots of considerations.
Yeah, similar like clouds work, right?
Mm-hmm.
They are squeezing everything out of shared infrastructure.
Yeah.
Yeah, makes sense. So maybe now the last one, given the LLMs and generative AI space, a general question, what do you think is the future for open source? Do you have any predictions?
So, if you had asked, right, like 6 months ago, 9 months ago,
Yeah.
it looked like, right, OpenAI, like they got a huge lead, like
Yes.
the open source catching up. But I mean, it's been amazing this year to just see how quick the open source community has come together, whether, you see it in meetups like that Hugging Face hosts where thousands of people kind of show up to do this, whether you see this in the development of LLMs where literally like dozens of companies have released large language models like this. So there's a lot of excitement, a lot of growth in this. So I think, there's a lot of people rooting for the open source, and the open source has been doing tremendous. And if you look at where we are with the latest kind of models, for example, the Mistral model that's coming out, like the Zephyr that Hugging Face is releasing, like there's a lot of performance that people are getting out of these open source models. So,
So what do you think was the main accelerator for this? Was it Meta's release of Llama, I guess?
So yeah, Meta was a huge player in this in terms of like releasing those models and kind of, giving people a methodology, giving people kind of hope that there's kind of ways to do this like that. I think a lot of it though is just the open source, like it's a collaborative thing, but it can take a little bit of time for the people to come together. And especially in the LLMs, like the building the large scale, like much of that information has been hidden behind, right? Like you have to go to find the people inside Google or the people inside, Meta or I don't know, one of the other companies. But that knowledge wasn't very dispersed. So it took a little while for that open source community to really take advantage of this. And I think this is also where you see that interesting thing of like the small LLMs and the people that are doing that, right? That was outside the mainstream. Like the people at Google and OpenAI weren't working on that, but somebody else had an itch and a problem. And now they found a huge audience for these kind of very efficient models like that.
Okay, so thank you for your time. It was a really nice chat. Yeah. And maybe you want to leave our listeners with some of the thoughts around what you're doing, what you want to share with them.
Yeah, no, I'm just excited about what's going on in the open source movement and like all the tools Hugging Face is producing. So like, look at us. We have lots of resources, packaging, tools, models for you to kind of go out and start working with like that.